Without memory limits, a single pod can consume all available memory on a node and crash everything running there. Here's how to prevent that disaster. Memory limits are set in the container spec using the resources block. You define limits and requests under each container. Limits set the maximum memory a container can use, specified in units like 256 megabytes or 1 gigabyte. This is written as 256 MI or 1 GI in the YAML. There are two key fields, requests and limits. Requests specify the minimum guaranteed memory that Kubernetes reserves for your container. Limits define the maximum memory your container can consume. The scheduler uses requests to decide which node can host your pod, while limits enforce a hard cap at runtime. If a container tries to exceed its memory limit, Kubernetes kills it with an OOM killed status, which stands for out of memory killed. The pod's restart policy then determines whether it restarts. This protects the node from memory exhaustion but means you need to set realistic limits. You can also enforce memory limits at the namespace level. A limit range sets default limits and requests for containers that don't specify them. A resource quota restricts the total memory usage across all pods in the namespace. These tools help platform teams prevent resource abuse. Set memory limits using the resources block to protect your cluster and ensure predictable performance. Practice this on Interview Mentor. Ready to practice for your next interview? Interview Mentor lets you answer real questions just like this one. After each answer, you get a detailed grade and personalized tips to improve. Watch your scores climb as you keep practicing.